Thank you for tuning in for the first event in Compost Awareness Week. So, this week is a set of activities for outreach and education about compost, how you can use compost in your garden, on your farm, in your landscapes, or in your planting boxes to grow the best plants you can. Or if you'd like to generate compost at home or divert some of your food waste and yard waste into the municipal or commercial composting stream, you can learn a little bit about how to do that as well. And you've got the privilege of hearing from a bunch of different experts who've agreed to collaborate and share their voices and their expertise on this project. So I'm Dr. Matt Bertucci with the University of Arkansas System Division of Agriculture. I'm in the Department of Horticulture, so I know a lot about plant production, and I've specifically got some students who are working on compost as a soil amendment. So you'll hear from me today, but I also want to thank some of our partners like the Cooperative Extension Office down in Little Rock. We've got a lot of great partnerships down there. Specifically, the Washington County Extension Office has been very helpful in hosting some of the events. We also have partnership with Food Loops, with Ozark Compost, with the Arkansas Union Sustainability Office, with the City of Fayetteville, and then also with Fossil Cove. And so with that, today's the first day. It's Compost 101. So we're kicking off the event with Colin Massey, who will introduce himself. And we really appreciate everyone's attention. And please tune in for future events throughout the week. Thank you.
Okay, well, welcome, folks. I'm going to move through this pretty well to make sure we stay on time. But again, I'm Colin Massey, Extension Agent for Horticulture here in Washington County with the University of Arkansas Division of Agriculture Cooperative Extension Service. And just some kind of learning objectives today. This is Composting 101. We're going to just talk about what compost is, how it happens. We'll go through its benefits and go through some steps on connecting garden productivity with food and yard waste. And we'll have some things at the end on troubleshooting. And really, this is based on best management practices. We're trying to give you the best possible experience if you're doing this at home. So you might say, well, that's not the way I do it. And that's fine. So that's why we have time for questions at the end. But really, the idea is one, yes, diverting organic waste from the landfill and turning that into a productive soil amendment. So this is some older data, this pie chart. This is actually from 2008. I'm going to show you an updated one from 2018, but it's what we kind of used in our traditional presentations on composting, looking at what goes into the landfill. So obviously you have things like glass, plastics, other textiles, paper. But the one I want to bring your attention to, again, back in 2008, was quite a bit, 14% both for yard trimmings and food scraps. And when these go into the landfill, getting buried, they're creating a lot of methane. It has to be either off gas or it's going into the atmosphere. And this really is about ways to divert that and get another use out of it. So looking at 2018, these are generated by the EPA. You can find this on their website. The nice thing is it looks like it's gone down a little bit for yard trimmings, a little bit better waste diversion on that at 12%, but still quite a bit of food waste that's getting into that waste system, up around 21%, wood 6.2%. Other things, that we may not be able to compost are still present there, and about 1.5 of miscellaneous organic waste. But it shows us there's still a lot of work to be done. And at least on an individual scale, collectively, we can help divert a lot of this and get a useful product out of it. So what is composting? And this is a natural process. It happens in nature as a function of our soils, but it's a process of decomposition and recycling of organic material into what we call a humus-rich soil amendment. And really, it's basically anything that used to be alive that has decomposed, and those nutrients are getting recycled and become available for plant uptake. And that's not just plant material, that's organisms, animals, etc. What it is not, it's not soil. And we can kind of get into the semantics there where someone says, hey, you need good garden soil here, put a bunch of compost in. Well, it's not quite the same. This pie chart shows you what soil is. And when we talk about native soil, we're really talking about mineral particles. And digging deeper into that, we'd really be talking about broken down particles of rock, different sizes. That's what we call soil texture. We have sand, silt, and clay that make up that mineral fraction. And in an ideal situation, the other 50% of that would actually be airspace, pore space in that soil for air, oxygen, and water to be able to move. And again, another ideal situation would be to have organic matter of 5%. Now, in Arkansas, we don't have that. It's more like 1.5 to 2%. But of that organic fraction, we have humus, we have plant roots, and microorganisms. And I'll tell you what humus is in just a minute. But for our purposes here today, when we talk about compost, we're really going to be thinking about it as a soil amendment, not making soil itself. It's a component of soil. So if we look at a similar pie chart of what compost is or soil organic matter is, we have about 10% that's fresh residue that could be fresh grass clippings or leaf matter. About 5% of that's going to be living organisms that range in size from microscopic up to small mammals. Earthworms are going to be a part of that. And then we have this active and stabilized fraction. The actively getting broken down matter makes up anywhere from 30 to up to 50%. And that term I used before, humus, is what we would call stabilized organic matter. It's been broken down, it's ready to be used, and it's ready to start releasing nutrients to organisms and to plants. And a really nice way to think about organic matter is it's really kind of the glue that holds soil together. So if you go and dig a shovel full of soil and you find that you have these kind of clods, we call those aggregates. Organic matter is what's helping make that stick together and not just sift through your hand like sand would. And generally, using this as a soil amendment is going to improve properties for any kind of texture of soil. And again, when I mean texture, I mean, is it really sandy? Is it really silty? Or is it very clay? You're almost going to always get benefits by incorporating organic matter into that. So just looking at what it improves, it helps improve soil structure. Again, that's like the integrity of those aggregates and the integrity of those pore spaces. An example of poor soil structure would be soil that's very compacted and maybe doesn't drain well or water's not able to infiltrate, not a lot of room for organisms and earthworms to move around. It can help improve soil texture. It's going to improve aeration. Plant roots need oxygen. So the more pore space that we can get in there, the better they're going to be able to pull in oxygen and function at maximum productivity. It's also going to help water holding capacity. Additionally, it's going to promote soil fertility. Now, compost itself is not what we call a hot fertilizer. It's not terribly high in plant available nutrients right away. If we think about a very common fertilizer that we would see would be like a triple 13, 13% nitrogen, 13% phosphorus, and 13% potassium. Compost would be about a 1-1-1, but it's going to act as a slow release fertilizer and over time gradually release those nutrients into the soil. It can be helpful in promoting erosion control, healthy root development. It's definitely going to attract more earthworms. And just by introducing compost as a soil amendment or adding it, it's going to greatly amplify your soil microbiology, which is critically important for nutrient release and soil health. And it can be free. A lot more people are using it now, so you don't see that as much, but it can be purchased in a lot of municipalities. It's a great way to reduce waste, recycle nutrients, and can be a very fun educational activity for your own family or in school settings. And again, a great soil amendment to help improve garden productivity. So here's kind of what the process looks like. We need 4 major components as our building blocks, and that would be our organic material, and we'll talk a little bit more about what that is. We need oxygen, we need moisture, And we need those microorganisms that are going to really be the ones that are breaking that down, all the way from chewing it into smaller pieces to really incorporating it and breaking that down almost to the nutrient level. But there's some factors that we can have some control over, which is time, and also heat is a major component in this recipe. Let's take just a second and differentiate something, compost versus mulch. As we stated early in those slides, compost, that's organic residues that have been piled, moistened, and then they've been allowed to undergo aerobic decomposition. And by aerobic, I mean oxygen is involved. There are certain soil microbiology that can function in anaerobic conditions or in the absence of oxygen, but we're really trying to focus on aerobic. Mulch is a material that we spread over the soil surface to help suppress weeds, control moisture, and help regulate the temperature of the soil. Now, it will break down over time and basically become compost. And sometimes we can kind of use compost as a mulch if we're just top dressing it. But I wanted to make that distinction so that we're getting our terminology correct. I'm having trouble seeing the top of my screen here. There we go. So, organic material for composting. Kind of breaking this down really in a more simplistic way, it's basically we have greens and we have browns as far as our organic material goes. And quite a few choices when we're looking at our greens. When we talk about greens, we mean something that's really containing more nitrogen. And when we talk about brown material, those are more carbon based. And we need to find that balance. So with greens, we have things like grass or plant clippings. Manure would be considered a green material. Kitchen scraps like fruit and vegetable peelings, coffee grounds. I'm not as high on eggshells as I used to be. They do take a long time to break down, but they do contain calcium, but they really have to be broken up quite finely. And kind of an oddity here, hair. If you've got a friend that's a hairstylist or a barber and you want to really jumpstart your compost, hair has quite a bit of nitrogen in it, like a 3-to-1 nitrogen to carbon ratio. For our browns, you're often using fallen leaves, finer woody materials, straw, or even paper. And on the paper, I would say just natural paper, not some kind of the mailers that you get that have kind of feel like they might have like a plastic coating on them, but newspaper or like what grocery bags are made out of would be a really nice option as well. So a little bit of science here. Kind of looking at, I mentioned we need to get our ratio correct, and the ideal carbon to nitrogen ratio for composting is about 30-to-1. So carbon is providing a lot of, carbohydrates. Nitrogen really is our protein that those microbes need. If we have too much carbon and not enough nitrogen, those microbes aren't going to be able to function at their maximum capacity. And we see that in the graph on the right. If we have that ratio right, our compost pile gets hotter and it takes typically less time to get a finished product. Versus as we go up in our carbon being that first number, it doesn't get as hot and it takes longer. The good thing about composting, I'm a pretty lazy composter. It kind of depends on your schedule. If you're needing it fast, you want to make sure and hone in that ratio. If you're a lazy composter like me, it's still going to happen. It's just going to take longer. So it's really a choice that's up to you. The importance with the temperature that might be important, especially if you're using something like grass clippings that may contain weed seeds, is that once we get into that 140 to 160 range, that compost pile starts to get hot enough that it can denature or kill a lot of weed seeds and sometimes even plant pathogens. And it can be a little bit difficult in a home composting situation to achieve that temperature because it requires a bit of a larger pile and a little bit more management as far as turning and monitoring moisture. But when we think about like our city of Fayetteville municipal composting, more of a kind of industrial level, they're really able to achieve this quite quickly. And that's why we really don't have issues with weed seeds popping up very much in compost that is coming from a municipal facility because it's getting hot enough and killing those seeds. So on the left, we just have some examples of carbon to nitrogen ratios of different material. So like arborist wood chips or coarse wood shavings would be like 700 to 1. That means we need a lot more green material to offset that, as opposed to something like fall leaves being around 60 to 1. And then our greens, we have about 20 parts carbon to 1 part nitrogen in coffee grounds, similar for grass clippings, and then vegetable peelings, about 10 to 12 parts carbon to nitrogen. So what does that mean? We can, well, I missed a slide. Well, I'll just mention it here. Um, if we had fall leaves, 60 to 1, and we had our, let's say, grass clippings and some vegetable peelings, combine that for like a 30 to 1, that'd be 90 total parts carbon to 3 parts nitrogen. And we divide that out, we get a ratio of 30 to 1. So you can't have compost without insects and microbes. And this is just an example of some of those. Uh, Obviously, the larger the insect, things like centipedes and our pill bugs, as we see in the bottom left, are really responsible for increasing the surface area of that material. A lot of these are chewers. They're chewing on dead plant material that's fallen off and they're making it smaller. And then we get down to that microbial level and a lot of importance on our bacteria and fungi. Very highly present in soil and critically important to us even existing. But they're very responsible for further decomposition, breaking these products down, incorporating them, they poop them out, and that is what makes those nutrients start to become available to plants. There's also organisms called actinomycetes. They kind of look like bacteria but function like fungi. So they all play a critical role, and most of these that are in soil are beneficial bacteria, beneficial fungi. Some of them are even predatory on pathogenic types of bacteria and fungus. And I encourage you, if you are composting or you're thinking about getting into it, go out at night, dig around a little bit, take a flashlight, and you'll just see it teeming with activity. Lots of different types of little centipedes, millipedes, all kinds of cool critters that you can actually see, and they do tend to be quite active at night. This is from a compost pile I had a few years ago and went and decided to check it out. Very, very neat to see. So, kind of asking how long does it take? I mentioned before, it depends. If you're actively managing this, you have a good sized pile that you can turn often, you can usually get a finished product within 3 to 6 months. Again, the city of Fayetteville, like a municipal scenario, they've got these big machines that go over and are constantly turning that. They're very large piles, almost 6 feet tall. They're getting finished products within months, versus me in a little bit more of a static situation with a smaller pile. I'm pretty happy to get something, once a year that I can go top dress and fill up the raised garden bed. The type of material does matter. Larger material is going to take it's going to take those insects and microbes longer to break down, versus if you have a way to increase the surface area and make it smaller as you start. So something like maybe a leaf shredder will help accelerate that process. And then location matters. We don't want too much shade. We don't want too much sun. I think finding a happy balance there. It certainly can be done in full sun. You're just going to have to stay on top of keeping that pile moist with watering a little bit more often. And again, it really comes down to our ratio. We're looking at about half to 3/4 of brown carbon materials to about 1/2 to 1/4 of that green material. And again, it's going to happen no matter what. This happens in nature. So, I mean, if compost didn't happen, we wouldn't be able to go hike in the woods. We'd be up to our ears in leaves. So, in a healthy forest ecosystem, this is happening on just about an annual basis. Some examples of ways that you can do this at home. We have a compost demonstration site here at the Washington County Extension Office. We'll be visiting that this coming Friday for our compost field day. I hope you make it out for that. And there's a lot of demonstrations out there of ways that you can do this. And I've done 3 different ways just at my house. The middle picture in the bottom, kind of sad looking, was my first attempt at composting with some old pallets. It kind of did this bin system. The thing you got to think of when you're using wood is it's going to break down over time. It's going to have a lifespan. So that was towards the end of its life. I was about to take it out and decided to go ahead and snap a picture. There's a number of things that you can bins that you can buy, bins that you can make, some that will actually lay on their side that you can rotate, or you can just do it in a large pile like you see in that middle picture on the top. Whatever way if you need to keep it contained or if you don't, that's really up to you. So it's a bit of a blank canvas. The picture on the top right and the bottom right are the rolling compost bin that I've been using the last several years. It's made of plastic. I think this I just emptied it last week, and I think it's done for. It got a crack in it, and it's getting harder to turn with a lot of material in there. But I got it used from someone. It lasted about 10 years, which I felt like is a pretty good run. But it's still something you've got to keep in mind. You still got to add water from time to time. And really, with any compost pile, you need to inoculate it. Just throwing those leaves and vegetable material in there alone and water, it's probably not going to do it. You want to jump start it. So anytime I'm starting a new compost pile, I go take about a shovel full of native soil and I toss that in there with it because I know that those bacteria and fungi and probably some little critters are already living in there, and they're going to find themselves in a pretty hospitable environment and start reproducing and uh, grow their population. Um, and then on the left, I just had a photo of kind of my holding container. When I got some finished compost, I wasn't ready to use it. I just put it into this yard waste tote. I put some holes in it so that it could breathe and held it there so I could start a new batch of compost. And when I was ready to use that, it had some wheels on it. I pulled it over to the garden and top dressed it, just like you see in this photo. That's my small, humble little side garden where I've taken that compost and just top dressed it. You could also incorporate this, especially if you have some heavier clay soils. That's going to possibly be a benefit to incorporate that in, especially if you're developing a new garden. Okay. So again, this is kind of recapping what we just talked about. Selecting a bin that fits your needs. Those smaller materials are going to break down faster. And I would highly suggest to not just dump and run. Don't throw it on the top like you see in the bottom right and leave it. If you can incorporate that material, one, it's going to break down faster. Two, it's going to make it a little bit less attractive to critters like rodents or raccoons or possums to come root around in there, possibly make a home because there's a nice food source there. Some people will even cover this with fall leaves or even a tarp to try to keep them out. When I was that composting with that bin system you saw earlier, my biggest pests were a couple of dogs that were getting in there and digging around, so I had to build a little gate to keep them out. So just keep that in mind. If you can incorporate it and cover it, it's going to make that less attractive to things that you don't want in there. We're going to balance our brown and greens, try to achieve that 30-to-1 ratio. And as I mentioned before, add a pound or so of good topsoil or native soil as your inoculant. And I know there are also some products out there. I think a compost jump starter that has those microbes already in there. You could use that as well, but soil is pretty free if you can afford to dig it. Select a good location. Too much sun's going to dry it out too fast. Too much shade may just mean you're going to wait a little bit longer to have that finished product. And then a critical component of, especially if you're trying to speed this along and get something within several months, is regularly going out and turning and mixing that pile. A good manure fork or a pitchfork When you're going out there to add moisture, that's a great time to turn it over and mix it. That's also introducing oxygen. Remember, we want aerobic decomposition. We want to promote oxygen in there so that those microbes can breathe and respirate and metabolize that. A finished compost, like you see in both of those photos, it should appear as dark brown, even to black. It should be fairly loose, and it really shouldn't have much of an aroma, just kind of an earthy aroma that comes from those actinomycetes. All right, some troubleshooting real quick. What not to do? Now, I'm not saying that, I mean, these things are organic materials. They will break down and decompose. But again, we're trying to give you, in the home situation, the best management practices for a good outcome. So for a home compost pile, I'm not really going to want to put meat, bones, or poultry or fish in there. Uh, thing, Things that have maybe a lot of oil, like fatty foods, whole eggs can be really stinky. I made that mistake once on accident. Dairy products. I've gotten some pushback on this before, but I would not recommend pet waste. Our pets have very specialized diets. They're very high in proteins and nitrogens and are often have a lot of E. coli and fecal coliform. It's not something I'd be wanting to put around things I might be eating. Again, a home compost pile may not be getting hot enough to kill those pathogens. So I'm going to say don't do that. I would be careful with weeds that have seeded out. You don't. We want to go apply this for a productive garden. We don't want to create a really nice haven to germinate new weed seeds. So be careful what kind of plant material you're putting in there. Treated wood, the laws on this have changed quite a bit. I think it was 2013. Uh, Pressure treated wood lumber used to be treated with arsenic. Again, not something we want to build our raised beds out of or necessarily our compost piles. Now it's either water-based or copper-based treatments. Copper's used as a natural fungicide, but that's again a kind of a personal choice. But we want to make sure that we're trying to make this not as attractive for pests. They may be more attracted to things like meat or dairy products. It could cause a lot of rotten odors. If we're not putting those things on that no-go list and we do have like an ammonia type smell, it probably means it's too moist and we might need to add a little extra plant material, brown material, and turn that a little bit more often. I'm sorry, that was a rotten odor. If we get an ammonia odor, that maybe means we have too much nitrogen. We've added too much greens, and we can offset that by adding some more of those fall leaves. If we're getting too low of a temperature, it means our carbon to nitrogen ratio is probably out of balance, and we might need to figure out a way to correct that. And then again, we need good aeration to keep that breaking down and get that up to temperature. I've got about 4 minutes left. One quick side note. I mentioned compost almost always has benefits when we use it as a soil amendment. But one common mistake that I see is not so much when, but how, is with regard to planting trees. Um, and I get it. You want to give good, rich soil for this tree to really take off. But in Arkansas, with our heavier clay soils, we might be kind of making what's called this bathtub effect, where we've dug out this hole, we're going to plant a tree, and we fill it with nothing but organic material. And that kind of creates a pot in that soil. Soil is strange in how water infiltrates it. It will tend to infiltrate one texture before it goes to the next. So if we have this rich organic soil, the water may just stay there and create like this bathtub and possibly drown our tree and drown out the roots, and also won't encourage them to venture out into that native soil to seek nutrients and water. So we typically recommend no more than 10% of compost being mixed in to try to backfill it with native soil so you don't drown your tree or your shrub. If you are purchasing compost, I highly recommend, getting that. We've had really great results using that from, I know the city of Fayetteville. I haven't used it from some of the other cities, but they typically do send this off to a private lab for tests. It'll show you the nutrient content, the pH. They'll look for residues in there, make sure they're under thresholds. I would be cautious if you've got a friend that has a horse farm that says, hey, I've got a bunch of composted horse manure that you can use in your garden. Horses require very high quality hay, and that typically means very weed free. And if that field had been sprayed with Grazon, the animal eats it, it doesn't bother them. But some of those chemicals tend to have a long residual after they've gone through that process. And nightshade plants like tomatoes, eggplants, and peppers are very sensitive to it. So ask a lot of questions before you're picking up composted manure that field has not been sprayed. But do check out the analysis. Most of the city's websites will include that. Do check out our website. It's uaex.uada.edu. We have a lot of resources on composting. Basically, what I just went through on the left, kind of understand the process. And then we also have some build outs for how you can build a bin. It'll also, I think we have one that talks about different containers that you can use to do composting at home. We may have some on there on worm bins and vermicomposting as well. And of course, we have a kind of a landing page for compost and composting resources that you can find all of those fact sheets on. And I think with that, I've hit my time. I'm going to stop sharing.
Thank you so much, Colin. I really appreciate that presentation. And we've had some people sending questions in the chat and in the Q&A. So if people want to keep sending questions for Colin, we'll get to them at the end. We're going to, in the meantime, watch a video that Dr. Bertucci pre-recorded on composting digging deeper.
Okay, everyone. Today I'm going to talk to you a little bit about digging deeper and using compost as a soil amendment. So on the left are our unamended vegetable beds. So we would have tilled up the ground, formed a raised permanent bed. And then on the right, you can see where compost was introduced as the soil amendment. And that was used as a surface mulch. And then between the rows, we have wood chips for our walkways. So let's talk a little bit about how you can use that compost as an amendment to benefit your plants. As far as today's presentation, I'm going to start with describing why we amend our soils, discuss the importance of soil testing, the characteristics of compost, a little bit about how to test compost and what we're doing to test compost for you, and then an understanding of some hazards and contaminants with composting and how you can mitigate that risk. And I'll provide some resources that you can access. So beginning with the importance of soil testing, the reason that soil testing is critically important is you must know what you've got. What nutrients do you have in your soils, and what nutrients do you need to introduce to your soils? In addition, you need to know what your pH is. That's one of the biggest things to understand, because the more acidic a soil becomes, or the more alkaline or basic a soil becomes, that can affect the availability of those nutrients in the soil. So you need to have your pH at the right level so that plants can access the nutrients that are in your soils. And an important thing to know about the soil testing, it is free for Arkansas residents. You just need to check with your local extension office. And at the end of this presentation, I have a video with Matt Fryer that you can access. Very, very good video about how to test soils at your home. It would also apply to your farms. And we have digital media and hard copies of the soil test report and how you can interpret that soil test report, as you see here on the right. So let's ask ourselves, why do we amend our soils? So we have a couple of immediate reasons that we would amend our soils. The first would be to add nutrients as a fertilizer, to introduce nitrogen or potassium or phosphorus or any of our other macronutrients or micronutrients. Another reason we might do it, especially with compost, would be to add organic matter. That organic matter in a mineral soil can really help the soil bind together and form a structure That structure gives increased porosity and water infiltration. And so organic matter can really be a benefit for soils. So that might be another reason you amend your soils. As I mentioned previously, we might want to adjust our pH to get it into the right levels. And with compost, another reason, especially with a surface soil amendment, you might want to apply some sort of mulch, either for water retention or for weed suppression. More long-term goals would be looking at increasing soil health, sequestering carbon, trapping carbon into the soils, and reducing your inputs. If you have increased water holding capacity in a soil site, then you might actually get away with reduced irrigation over the course of a season. Pictured here on the right, I just wanted to show you, these are 4 different sources of nitrogen at the same nitrogen concentration. So that's the same amount of nitrogen, but at the top left you have feather meal, the top right is urea, then you have blood meal, and you have fish emulsion. So the same quantity of nitrogen actually requires different amounts of different fertilizers, and I'll discuss that in a later slide. So we're amending our soils because properly amended soils have the plant nutrients that are available to plants, and they have appropriate drainage and water retention for our crops. So we dial everything in perfectly so we get this nicely growing plant. If you want to grow the best crops, you have to properly manage the soil. Now, let's take a look at the nutrient content of some synthetic fertilizers. This is going to be different than our composts, but something that you should see whenever you're at the co-op, at a retailer, or wherever you're buying your fertilizer, even online, you might see a sequence of 3 numbers. So look at this bag on the right, 4600. Now look at the 3 columns to the right of this graph, and that's what these numbers refer to. 46 is 46% nitrogen, 0 in the middle represents 0 phosphorus in the form of P2O5, and then the last 0 represents potassium, so 0% K2O, or potassium. So that urea fertilizer only contributes nitrogen to the system. So looking at some of the other fertilizers we have, if we go down to normal or triple superphosphate, that is 0 nitrogen, 20 P2O5, 0 potassium, K2O, or 0 nitrogen, 46 P2O5, 0 K2O. And you can see all sorts of different numbers for different synthetic fertilizers. One thing I want you to look at is that you have 46, 20, 46, 59, 39. These are relatively high concentrations of nitrogen, phosphorus, and potassium, especially when we compare them to the organic fertilizers. Here we have the nutrient content of selected and natural and organic fertilizers. So we have the same columns that we saw on the previous table with N, P2O5, and K2O, but you can see that the numbers are much lower. We don't have 46% nitrogen in any of these materials. We don't have 62% potassium in any of these materials. Instead, we have, at the highest in our nitrogens, we see 10% in guano, 14% in blood meal, 10% in fish meal. They're not as nutrient dense as our synthetic fertilizers. As a general rule, these would be the values that people estimate for compost. 2% nitrogen, 1% phosphorus, and 1% potassium. However, not all compost is the same. And I say that because that's why I'm talking to you today about how do we amend our soils with compost? Well, we need to know about what material we're putting into our system. We need to test our soils, and we also will need to test our compost. You can imagine that the home compost that I have in my backyard looks very different than what is managed on a municipal or commercial scale like you see at the bottom right. The good news is we can get this tested at the Fayetteville Agricultural Diagnostic Laboratory or with private companies. So this type of testing is available to homeowners, to gardeners, or commercial producers. And the reason that we really are motivated to do this testing is compost is actually only regulated as a waste product. The state and the federal government look at composting as a way of mitigating waste to landfill. And that, for that reason, they only regulate materials that are potential contaminants or, to the environment, or harmful pathogens to the human population. So the ADEQ, the Arkansas Division of Environmental Quality, has rule number 22 and solid waste management rules that has all the stipulations for how this material must be tested and regulated and managed, but viewing it as solid waste and waste management. So their required testing means that they need to make sure that the compost pile gets to temperature for a certain period of time. This is part of their pathogen reduction plan. So they make sure that they get to enough temperature that they should be suppressing things like salmonella and E. coli, fecal coliform bacteria. But they also test for those bacteria actively. They will test and make sure that it's free of salmonella, free of E. coli. They test the pH, and then they do test for metals. So they test for arsenic, cadmium, chromium, copper, lead, mercury, molybdenum, nickel, selenium, and zinc. Those are all things that they're concerned about getting harmful, getting into the environment and causing some sort of pollution event, some sort of harm to the environment. So if the state gives us their report, they'll tell us, here's your compost. It's free of pathogens and it doesn't contain pollutants. Does that give us the information we need to amend our soils for growing our crops? Are we ready to then put out our compost with information that we need to get the right nitrogen content, the right calcium content, phosphorus, potassium? No, we don't have that information based on the state requirements. So for that reason, my graduate student Rachel and I are working on a USDA NRCS funded grant. We looked at the fact that there are 51 permitted compost facilities in Arkansas, and we told the USDA NRCS, because the state only tests for environmental concerns or pathogens for human populations, and horticulture is the #1 consumer of compost, we think it would be beneficial to test those composts for its fertility characteristics and its nutrient characteristics for soil amendments. And we actually have contacted 11 active compost facilities. The unfortunate thing is, while the permits have been administered to 51 facilities, far, far fewer are actually active compost facilities. And thus far we have 11 partners, and we have found many, many who are just permitted but are not actively composting, unfortunately. As far as the testings we are conducting, we're looking at bulk density to characterize the mass per volume of this material. We're going to characterize the pH as well. Then we look at the macro and micronutrients that you would want in a production system. So that's potassium, phosphorus, calcium, etc., all those important nutrients. We look at the total nitrogen, both in the form of ammonium and nitrate, the total carbon, the carbon to nitrogen ratio, and the electrical conductivity of this material. So what goes into the compost? It really depends on the feedstock, as Colin talked about. We have food waste, yard waste, biosolids, which would be manures or wastewater treatment facilities, so fecal material from the water systems, and then any combination of that material. We also need to be aware of the age or maturity of the compost, and then the management of the compost. So is this a commercial scale compost facility? Is it the municipal compost facility? Or is it just a home composting pile? And I bring that up because municipal and industrial or commercial compost facilities generally can handle things that most homeowners aren't going to mess with. So at the city of Fayetteville, for example, they have food waste drop-offs, and they can handle cooked meats, bones, things of that nature, shells of cooked crawfish, for example. I'm not about to put 30 pounds of crawfish shells in my compost pile at home. I don't have the volume to bury that and get that composting well. So that's fortunate that we have the ability to drop that off or we have some curbside pickup programs that are even being piloted. Now, I mentioned the age or maturity of the compost, and I want to bring this up because it's important that we understand that composting is an active microbial activity, and if that microbial activity is occurring, then the compost has not yet matured. So this graph has temperature on the y-axis going up and down, and it's the temperature of the compost pile. And then on the bottom axis, on the x-axis, is time. So we have this period of time where heat is accumulated, heat is being generated by those microbes, and it's really not compost yet. That's a pile of organic materials that are being fed on by our microbes. After the temperature stabilizes, it's an immature compost, so it's staying pretty hot, and as it matures, it will begin to cool. It'll be closer to an ambient temperature as opposed to 140 degrees or 130 degrees. And as that compost cools, that means it's getting a lot closer to being a soil carbon amendment, something that would be appropriate for amending soils. And I want to remind everyone that compost is a slow release fertilizer, so we need to get that compost out ahead of the plant needs. Synthetic fertilizers are generally immediately plant available, whereas compost and other organic soil amendments, they take time to break down, to mineralize into the plant available nutrients. So you need to introduce it to the system a little bit ahead of time, 7 to 10 days before you're transplanting or you're seeding should be a good rule of thumb. Now, you want to check the source of the compost that you're using. Is it yard waste? Is it food waste? Is it both? Does it contain biosolids? And you might want to look for tests or check if the material has already been tested for that nutrient content. If it hasn't, it might be something you consider submitting for testing. For example, here, the city of Fayetteville in 2022, they did post their compost results, and they separated it by food waste and yard waste compost results. You need to recognize, though, this is the test from the city of Fayetteville's compost, the lab submitted samples that they tested. You would need a lot of compost to meet most of your fertility needs. If you look at this test from 2022 for their yard waste compost, it was only 1.2% nitrogen. 1.2% nitrogen as opposed to 46% nitrogen in urea or 10% nitrogen in blood meal. So you would need 10 times the amount of compost to meet the same amount of nitrogen in blood meal, or 46 times the amount of compost to meet the same amount of nitrogen in urea, right? So that means you need a lot of compost. Alternatively, you could just supplement your nitrogen needs with other fertilizers, with getting credits from previous year's cover crops or residues from the previous crops. So generally, compost is not going to get you all the nitrogen you're going to need for your production system. So keep that in mind as you amend your soils. Now I have some cautionary tales. Herbicides can show up in compost. They shouldn't if everyone's following the rules as intended, but it can be a problem. If certain herbicides have been used in the source vegetation or manure, it can actually then get into the compost. It can persist through the composting process, and then those herbicides could be active where you spread that compost. Generally, the biggest concern is material coming from hay or grass clippings or manure from pasture systems. So it's a reminder that producers, cattlemen specifically, should be reading the label and following the label, and even just looking at pictures, right? So here's Milestone. That's the product that contains aminopyrrolid, and there's graphic pictures, making sure that people don't spread that manure for tomato and vegetable production or for composting. The problem is if your neighbor offers you his manure for your vegetable garden and he's being kind and generous, but you don't realize he's sprayed Milestone or he's sprayed some of these other chemicals, that's when problems happen. So these are the chemicals that have the capacity to carry over. On the left is the trade name, in parentheses is the active ingredient. So most of them are coming from pastures and hay fields. aminopyrrolid, clopyrrolid, picloram, 2,4-D. Notice that they have to have the other materials plus 2,4-D to really carry over. In turf and lawns, some materials have clopyrrolid, and in commercial vegetable systems, only the product Stinger contains clopyrrolid. So if that has been sprayed on the vegetation, or if there's manure from animals that grazed on that material, it's not suitable for composting. Now, I'm not here wagging my finger at our at our cattlemen. I'm not trying to say that they shouldn't use those herbicides ever. I'm just saying that it's important to understand the consequences of this class of chemistry, and you must be conscious of the downstream uses of your manure, hay, and straw. And if you're interested in compost, you need to understand if that manure, hay, or straw was the source of the feedstock. However, if you are concerned, if you do think that might be the case, don't spread that compost on your property. Instead, you might consider conducting a bioassay. A bioassay is just a test with living plants or with seeds to see if that compost has any harmful inhibiting effects on plant growth. So you test it with seeds or seedlings or container grown plants, and you look to observe if any harmful effects are observed on this sensitive crop species before you spread it on a site. So that's a good way to test to make sure that you don't have any of those harmful chemicals in your compost before you spread the material. So the key takeaways for this, look, test your soils. That's a free service from the Cooperative Extension Service. Talk to your extension agent in your local county about that. Test your compost or look for the nutrient info. That would not be a free test offered by the university or Cooperative Extension Service, but it is something that could be done if you communicate. Remember that you're probably going to need to supplement with other fertilizers. Compost is not going to be the sole source for most of your fertility needs. Be careful of immature compost. Compost that hasn't finished can have problems for nutrient release, and it can be problems for plant growth. And if you're unsure about any sort of harmful plants or harmful herbicides or things, if you have immature compost, for example, you can conduct a bioassay just to check and see if your plants respond well to that material. As far as additional resources, you should take a look at these videos. Gardening from the Ground Up is a Division of Agriculture video that I thought was really good about soil testing. Matt Fryer also put together a video about how to soil test. Fantastic video. And as far as additional resources that are print or in digital media, these fact sheets are something that you should definitely consider looking at. I'd like to take a moment to thank my sponsoring agencies, including the Walton Family Foundation, the USDA AMS Regional Food System Partnership, USDA NRCS Conservation Innovation Grant Program, and of course the Hatch funding that funds state universities. So thank you all for your time, and I'd like to take some questions if possible.
All right, that was our video from Dr. Bertucci. You should now be able to see on my screen, hopefully, in case anyone needs to step out early before we finish questions with Colin. This is the schedule for this week. Tomorrow, we've got composting on campus with the University of Arkansas in the Union Food Court from 12 to 1. Wednesday, we've got another Lunch and Learn webinar from 12 to 1 called Not for Landfill, Composting for the Environment. And then on Thursday evening, we're doing a composting meetup at Fossil Cove Brewery in Fayetteville from 5 to 7. Or if you're located in Central Arkansas and Little Rock area, there's another meetup for Arkansas Farmers Market Composting Social at the St. Joseph's Farm in North Little Rock. And then on Friday, we've got another talk in Fayetteville at the U of A Division of Agriculture Fayetteville Research Farms, the Milo J. Schultz Research Farm off Garland. Anyone who comes and would like to bring a 5-gallon bucket, they can pick up their own compost. To register for that, you'll want to scan the QR code on the screen. And then in North Little Rock, just normal Little Rock, you'll do a Rebuilding the UALR Campus Garden Composting Systems Volunteer Action and Networking event from 4:30 to 7. And thank you for everyone who's submitted questions. If you would like to add a question to the chat, you're welcome to add them to the Q&A or to comment them to me directly. The first question we have is, you said that hair is great to add to compost. Do you know if bleached or dyed hair would have any effect or how beneficial that would be?
Interesting question. I haven't looked at the literature on that, but my gut don't go on that totally, but would be that in that small of an amount, if it's been in the hair for a while, it's probably going to be denatured or neutralized in the soil pretty quick. If it was straight bottle of dye or straight bottle of bleach, that could have some negative effects, but usually those are quite dilute. And I think that certain microbes would pretty well stabilize that pretty quick. But ideally, I would, if you're concerned about it, try not to use too much, all bleached or all dyed hair.
The next question is, can you test the nitrogen and carbon levels of compost the same way you test them in soil?
Yeah, I think Dr. Bertucci addressed that really well, and not really. I mean, in a way, yes. It's not part of our free soil testing package. Those instruments down in our Mariana soil test lab are calibrated for native soil. If it's too heavily organic, the results that you would receive if they didn't reject them would be very inaccurate. But we do have a Fayetteville diagnostic lab that those can be submitted to for a cost. I think for something routine, it's probably around $20 plus or minus. And it would give you the pH, it would give you the percent nutrients that are present there. The difference in the soil test is it's not going to come with an application rate or a nutrient recommendation based on what you're growing. It's something you have to calculate on your own.
Hmm. Yeah, that's my experience at the Fayetteville Agriculture Diagnostic Lab, is they'll do it for you, but you do have to pay for it. And I think they'll give you carbon and nitrogen. They'll do the weight loss on ignition for you,
Yes,
but
yes.
you have to pay a fee, and I think it's $12 to $20, somewhere in that range. The next question is, I saw something online about how compost can burn plants if it isn't finished properly. How do I know if it's too hot to use?
Yeah, again, I think Dr. Bertucci addressed this well. He had a graph for this. So I would encourage folks that are doing this at home to invest in a pretty expensive compost thermometer. I've found those as an analog thermometer, they do pretty good. But basically, he showed you those, that very active composting time where you're maybe in between 140 and 160. It's not compost yet. It's still actively being broken down and decomposed. So that certainly could, one, rob some nitrogen if you were to go apply that, and it could be just too temperature hot to put on. But I think once you start seeing that temperature during that cool off period, you're looking at 100 degrees or less. It starts to become much safer. When in doubt, I'd wait a couple of weeks until you're at a more closer to what the air temperature would be.
Mhm. The next question was also addressed a little bit more in Dr. Bertucci's video, but also have you touch on it. It's, please address hay, straw, lawn clippings, and manures that can have persistent chemicals. I used horse manure that was tainted, and it took 4 years to break down after seriously affecting elderberry plants. I had to go through a long process of contacting elderberry growers, sending photos to the extension office, diagnosing what exactly was the source of the chemical contamination, and educating myself on persistent poisons and their lifespan. It was a horrible, long, tedious experience.
I feel for that. We probably get at least 6 plant samples in to the extension office a year that have had this problem. I've got a colleague that's also a commercial vegetable grower that had this happen. Yeah, and if it's the right kind of persistent chemical, it can take 3 to 5 years for that really to work its way out of the soil. So Dr. Bertucci addressed that well. Make sure and in their case, they asked those questions, and it still happened. The biggest risk is going to be from hay, which I'm not a fan of using in any horticulture situation, because it's typically that grazon, that active ingredient pichlorum, is what those beans and nightshade crops are very sensitive to. I've never seen this problem in straw, which comes from wheat. That chemical is not if I looked, I don't believe it's labeled for use. And we have people that are doing straw bale gardening. For folks that are on limited spaces, they have not had that issue with their nightshade plants. But it's, again, knowing where it comes from, asking those questions, and when in doubt, I think if you're getting that from anyone where they haven't done testing, is to even just in a small like red solo cup, put some of that in there, put a bean or a tomato seedling, something that's going to germinate quickly, let it get 4 to 6 inches tall, and you're going to get a pretty good idea by then if it has any of that persistence in there.
Thank you. We also talked just a little bit about this next question, but aside from the visual cues, how do I know when my compost is finished? I use the Berkeley hot compost method, and it gets up to 150 to 160 degrees Fahrenheit, then back down to ambient temperature in about 8 weeks. But is the temperature alone enough to let them know if it has decomposed enough to be used in the garden?
Wow, I want to come get some of your compost. That's quick. That's a quick turnaround, and you're really hitting that temperature well, Rusty. I mean, definitely monitoring that temperature. If it's been in that cool down period, again, below 100, I'd say within 5 to 10 degrees of ambient air temperature, you're pretty safe. But giving it several weeks and making sure it's staying fairly constant at that temperature is a pretty good cue. And then I do this with soil when I'm deciding if I need to go water something. I feel it. I'm going to pick some of it up. I'm going to sift through it. I'm going to smell it. If it's got the right color, if it's pretty crumbly and doesn't have an off aroma, isn't hot to the touch, I feel pretty confident that I could go ahead and use that. But I think your temperature monitoring is really your number one metric for that.
Thank you. And then our last question is, Rusty, would love to hear your thoughts on using compost produced from biosolids. His city provides biosolid compost free of charge, but is wary of using it due to possible pharmaceutical residues.
Okay, wow, good question. I wouldn't say that I've done an extensive literature review of this. I wish Dr. Bertucci was here. He mentioned this, but I know there's some studies out there that look at these kind of things. Again, these facilities that are selling this have to go through state inspection, so I think that's something they probably, hopefully, are looking for. I can't say, 100% that all of them are getting stabilized and not having some kind of carryover, and what that effect is, I don't really know. But I know there have been studies on this that showed that under the right conditions and following the right steps, a lot of those things do get stabilized where they're not really moving into the environment. But I think it probably requires a more due diligent literature review to fully answer that.
Well, thank you so much, Colin. I really appreciate your time, and I appreciate everyone's time for joining us today during this Lunch and Learn webinar. I'm going to put back up on the screen the schedule for this week, as well as the QR code for anyone who's interested in joining us on Friday. We'd love to see you there, and I hope everyone has a good rest of your afternoon.